Today we are going to discuss the topic stack and the subroutine, which is a part of a unit 4. Uh, as far as the stack is concerned, we have discussed it many times in the classroom also. That a stack is a arrangement in which the data is temporarily stored in the memory. Of course, the arrangement is a different manner. This arrangement of a stack in which the data is being stored into the memory works either on the last in first out basis or first in last out basis. The meaning is very simple, that the data which has been put last can be taken out first, or the data which has been put first can be taken out last. And because of this arrangement, it is very much similar to the analogy whenever we are putting the things one over the another. It is called stacking of that thing. If you take an example of a book, if you are putting books one over the another, it means you are stacking of the book. So with the same arrangement, the data is being temporarily stored into the memory at a particular defined memory location. Of course, that memory location will be working as a stack. So stack is a memory location in the read-write memory that will be used for the temporary storage during the execution of a program. So whenever we put certain data into the memory, and whenever we are in requirement, we can take the data from the memory. But before using the stack, it is necessary to first define the memory location which will be used as a stack, and that location is called a stack top location. And for storing the data into that location and taking the data from that location, in which the data has been put one over the other, and just because of this analogy, it is called a stack arrangement. The different thing besides the stack is the subroutine, which we have to discuss in this unit also. Subroutine is a kind of a subprogram. This actually is being used in the condition that when the problem is very large. You can take an example. You can understand the subroutine in this manner, that if the program is very large, the problem is very large, what we used to do, we used to break the particular program or the problem into certain modules, and individual modules are being developed by the individual person, and each person who will be developing their module is called routine or subroutine or subprogram, and later on all the subprogram is merged together. The another application of the subroutine is, suppose we are writing any program, and that program uses certain set of the instructions many times in combination. So instead of using the same set of instruction many times in the main program or in the particular program, what we used to do, just to reduce the size of the program, what we do with that set of the instruction has been put somewhere else, taken into the consideration, and whenever it is required in the main program, it will be called. So subroutine is nothing but it is a subprogram having certain set of the instructions, and whenever it is required, you can take the help of that routine. So subroutine we will discuss later on, but today the topic which in this video we are going to discuss more detail about the stack. So as I told you, that stack is a memory location which is used to store the information, and to initialize this stack, it is necessary to go with the initializing the stack. Now, for initialization of the stack, we have already gone through the register organization of 8085, in which we have general purpose register as well as the special purpose registers. Now, in the special purpose registers, we have program counters and the stack pointer. If you remember, program counter is a kind of a register, 16-bit register, which holds the certain memory location, which indicates that the next instruction to be executed by the microprocessor. And so the second special purpose register is the stack pointer, which is used to hold the stack top location. So before we try to use the particular memory location as a stack, it is necessary to initialize that memory address into the stack pointer, and for that particular purpose we can use a simple instruction LXI-SP 16-bit memory address. Once the stack location is defined into the stack pointer, now that memory location and below that memory location we can use put the data temporarily into that. And for that purpose, we will be using two particular instructions for putting the data and for retrieving the data. For putting the data, we'll be using the push instruction, and for retrieving the data, we'll be using the pop instruction. So how it works, once we load certain memory address into the stack, stack pointer, that address which has been put on the stack pointer is called stack top location. So whatever data we want to put into the stack, the stack top location always remains empty, and whatever data we want to put into the stack below the stack top location address, it is being stored. And I have already told you that push instruction is used for putting the data into the stack or into the memory location, and pop instruction is being used for taking out the data from the memory location. Now, as far as the push instruction is concerned, the syntax of using the push instruction is very simple. Push RP. You can see push RP. RP stands for register pair. Now, we know that we have three register pairs in the 8085: PC pair, DE pair, and HL pair. And another register pair has been mentioned here, PSW, and this PSW is nothing but it is called the program status word. So one by one, I am going to discuss how this push instruction used to work. Of course, it is a single byte instruction. But before we are using push instruction and the pop instruction, it is necessary to have the initialization of LXI, initialization of a stack pointer, and for that particular purpose, LXI instruction is being used. So LXI SP is doing nothing. LXI SP 16-bit number, it is going to store the 16-bit address into the stack pointer, and it is that 16-bit address of the memory where we want to store the data in the form of a stack. Now push RP, how it works? Now push RP can be used as push B, push D, push H, and push PSW. And how it works? It simply stores the register pair data into the stack. This is a single byte instruction. Now how it works? It copies the content of a specified register pair onto the stack. But how it works? The stack pointer is first decremented by 1, and then the content of the higher order register is copied into the stack pointer location. Again, the stack pointer is again decremented by 1, and the content of the lower order register is copied into the location. So if we are using push B instruction, it means B register is the higher order register and C register is the lower order register. So with push B, what we want to copy the content of BC pair register into the stack. But before it is going to be stored into the stack, whatever is the content of the stack pointer, first it is decremented by 1. So if the stack pointer content is 3099, first it is decremented by 1 so that stack pointer will show 3098, and at that location the content of the higher order register, means the B register, will be stored at that location. Again, the stack pointer content is decremented by 1 so that it will become 3097, and the content of C register will be stored in that location. Similarly, it happens with the DE pair, it happens with the HL pair, depending upon the requirement. As far as the program status word is concerned, the program status word is nothing but it is also a 16-bit. It is representing 16-bit number. Of course, this program status word is a combination of accumulator as well as the flag register. We know that accumulator is of 8-bit. We also know that flag register is also of 8-bit. So combination of these two is going to give you the program status word. So it is the content. Now program status word is a combination of accumulator plus the flag register. So accumulator is the higher order register of the program status word, and the flag register is the lower order register. Now before that, whenever we are using flag with the help of any instruction, we have seen that whenever we are using flag, we are able to check that what is the status of the flags, but we are not able to store the value of the stack somewhere. But it is the beauty of this push instruction, with the help of which we are able to store something onto the into the memory. We are able to store the content of the flag register into the memory. So this is how this push instruction works. So push instruction is basically used to store the content of the register pair into the stack defined by the stack pointer register. Now as far as the pop instruction is concerned, it is used to retrieve the data from the stack. जो भी चीज़ें हम लोगों ने stack में रख रखी हैं, उसको retrieve करने के लिए we used to use the pop instruction. Now Pop instruction is again the syntax of writing the pop instruction is pop RP, where RP is again the register pair. What it does, it is also a single byte instruction. It retrieves the content from the stack back to the register pair. But since it is pop instruction is a counterpart of the push instruction, push is used to store the content of the register pair into the stack or the memory, and pop is used to retrieve. So since it is a counterpart, so it works just opposite to the push instruction. So if pop B is written, so what it will do, it will copy the top two memory location content of the stack into the register pair. But in case of push instruction, first of all, the content of higher order register is copied, then the content of lower order register is copied. But in case of pop instruction, first of all, the content of the stack top location is copied in the lower order register, and the content of the second stack top location is then copied into the higher order register. Now, in case of push instruction, first stack pointer is decremented by 1, then copying process is going to happen. But in case of pop instruction, first copying is done and then stack pointer content is incremented by 1. So first of all, the content of the memory location indicated by the stack pointer register is copied into the lower order register, and the stack pointer register is incremented by 1. Then the next memory location is copied into the higher order register, and the stack pointer is incremented by 1. Of course, push and pop instruction comes under the category of the data transfer instruction. Thus, the source is not modified. Source कभी भी change नहीं होता है, as well as flags का इसके ऊपर कोई प्रभाव नहीं पड़ता है. Now, where is the next slide? Let us go to the next slide. Now, the next slide is showing an example that how it works. And this example, a simple program has been written at 2001 LXI SP 3099. It is a 3-byte instruction. And at 2003 LXIH 42F2 is written. So first instruction, when first instruction is executed, what will happen? 3099 will be stored in the stack pointer. And it suggests that 3099 is the stack top location. When the second instruction is executed, 42F2 is copied into the HL pair register, where H will be having 42 and L will be having F2. Now, when push instruction is executed, push H, it means what we want. We want to copy the content of HL pair register into the stack, whose stack top location is defined by the 3099. So, what happens whenever this program is being executed, the first instruction, when first instruction is executed, stack pointer will be loaded by 3099. When the second instruction is executed, that is LXIH 42F2, what it will do, it will copy 42F2 into the HL pair. When the third instruction is executed, push H, as I have already told you, then that first it is going to decrement the content of the stack pointer. So stack pointer content was 3099, it will become 3098, and at 3098 the content of the higher order register, which is 42, will be copied. Again, the stack pointer is again decremented by 1, it will become 3097, and at 3097 F2 will be stored. So this is how the push instruction is being executed. Now, when push instruction is being executed, 2006 is being executed, at that particular time, stack pointer will be showing 3097. Previously, the stack pointer was 3099. When push H is executed, it becomes first 3098, then it becomes 3097. So, when push H has been executed, at that particular time stack pointer will be showing 3097. Now, when pop instruction is executed at 2010, what will happen? As per the statement given in the pop instruction in the previous slide, first of all, the content of the memory, which is indicated by the stack pointer, is copied into the lower order register. So what will happen? 3097 is already having F2, that F2 will be copied in the C register, and then it is incremented by 1, means SP stack pointer is incremented by 1, so that it will become 3098, and the content of 3098 will be copied in the B register 42, and again the stack pointer will be incremented by 1, so that it will become 3099. So what actually this program has done, with the help of this program, what we want to do, we want to copy the content of HL pair into the temporarily into the stack, and later on we want to copy the content of HL pair which has been put into the stack back to the BC pair. Push H is going to push the content of HL pair into the stack, and pop B will be copying the data from the stack into the B register. So this is how this works. So that is all from this slide, and the next portion of the stack we will discuss it later on. Thank you.